this one? You should know for the test tomorrow. Even the tangents. Yeah. Yeah. Even the tangents. So let's kind of look at these. I think you guys know that the signs go sine, cosine, cosine, sine. You guys know that. And and it goes positive, positive. It stays the same sign, right? And then you got to know the cosines go cosine, cosine, sine, sine. And it switches. If it's positive, it goes negative. If it's negative, it goes positive. Tangents, we didn't really talk about it. So let's look at this, right? It's positive here, then it goes positive on the top and opposite on the bottom. Same Z's here. You go same sign on the top, opposite on the bottom. Same, opposite. Same, opposite. Did anyone come up with a cheer, sorry, for the tangents?
And A minus D, all
So these actually aren't that bad. So this first one says sine of 2 theta. We're going to develop this formula by adding 2 thetas together. So how else could I write the sine of 2 theta? Well, I could write it as sine of theta plus theta. Okay? That's the same as sine of 2 theta. And then I could use the formula sine, cosine, cosine, sine, right? Because we're adding them. Yeah. So I have sine of theta, cosine of theta, because this one's my A, that one's my B. And then the sign stays the same, it's a positive, and then it goes cosine theta, sine theta. All right, there's nothing to evaluate, but what's neat about this is really one of these, and there's one of these, and it doesn't matter what order you multiply them in, so they're like the same, and you can add them to make 2 sine theta, cosine theta. That is one double angle formula that eventually is easier to memorize, or you could develop it every time. 2 sine theta, cosine theta. All right, so fill it in the box. Now we're going to develop the cosine one. There are 3 cosine 2 thetas, which all stem from 1. It's not actually that bad, okay? I have to erase so I have some space. So now I've got cosine of 2 theta, which I could also write as cosine theta plus theta, right? That's still 2 theta. And then I can use the formula cosine, cosine, sine, sine. So I go cosine theta, and if it's positive here, it's negative here. Sine theta, sine theta. All right, and then how could I simplify this? Well, cosine times cosine, because I have the same thing right here, that's cosine squared theta. And right here, because I have theta, I can do minus sine squared theta. Yes, Fabio.
What if it's like there are 2 different numbers being added or subtracted?
They're not, because it's 2 theta. So you guys, it's always 2 the same. Yeah. Yeah. All right, so that's actually one answer right there. So there's your first formula. So cosine 2 theta is cosine squared theta minus sine squared theta. So the way that we get the other 2 formulas for this one is we go back to our best friend, cosine squared theta plus sine squared theta equals 1. That was weird. All right, so cosine squared theta plus sine squared theta equals 1. So I could replace cosine squared theta with, if I subtract the sign right here, then cosine squared theta is equal to 1 minus sine squared theta. So I'm going to replace this right here with 1 minus sine squared theta, and then I still have a minus sine squared theta. So I'm using that number 1 Pythagorean identity and replacing cosine squared with 1 minus sine squared. Okay? So now these guys can add together right here. So there's minus a sine squared theta and minus a sine squared theta, which is minus 2 sine squared theta. So that's the next formula we could also write down. So cosine 2 theta is also equal to 1 minus 2 sine squared theta. How else could I do this? Well, instead of replacing cosine squared theta, I could also replace sine squared theta in this problem. So I've got cosine squared theta minus sine squared theta. And now I could replace sine squared theta. So if you isolate the sine squared theta in this equation, you get 1 minus cosine squared theta. And distribute your negative sign. So that's a negative 1 and a positive. No. Right? I'm solving for sine. I'm keeping the sign, and so I'm minusing cosine squared theta and minus. Okay. Right. So distribute the negative sign, and then I can add these together right here. And I have 2 cosine squared theta minus 1. So all 3 of those are double angle formulas for cosine. Probably I would only memorize this one, right? Because you know to plug in those other 2. I would probably only memorize that first one. All right. Now we've got tangent of 2 theta. Never have enough room on these. So tangent of 2 theta. So we're going to do the same thing. We're going to write it as theta plus theta so that we derive it. So we got to memorize this formula by tomorrow, right? So it's tangent A plus tangent B all over 1 minus tangent A tangent B. Okay? Make sure you make a little flashcard, whatever you need to do. That would be this one right here. No. So this one is just going to be tangent theta plus tangent theta instead of A and B, because I have theta and theta. And then in the bottom, it's going to be 1 minus tangent theta times tangent theta. Sorry, I wrote that really small and squeezed it in. So in the top, I have tangent theta plus tangent theta. What do you guys think that's equal to? Yep. Nice. And in the bottom, I have 1 minus, what's tangent theta times tangent theta? Good. So you may not have to memorize this one. If you do want to derive it, it's not very hard to derive. All right? So the last one for double angle for tangent, we're going to fill in 2 tangent theta over 1 minus tangent squared theta. Now we're going to skip all of these until Monday. No, we're going to do these on the back. Just these 2. No.
Are there whiteboards?
Yes. All right, here we go. Cosine of alpha is 3/5, and sine of alpha is less than 0. Find the sine of 2a. Yeah, what does that mean? So, well, what we can do for sine of 2a is we can just know our formula. Wow, that was really bad. All right, sine of 2 alpha. And so you could just memorize it. 2 sine alpha cosine alpha. Okay, that's just the for double angle of sine. And now I know one of those because they actually just tell us cosine alpha is 3/5, right? So here's cosine alpha. I can replace it with 3/5. What I don't know just by looking at that top part is sine alpha, but this tells us what quadrant we're in, and we can draw a triangle. So I'm going to make little XY axes. And I know cosine's positive right here because I have a positive fraction, and sine is negative because it's less than 0. So cosine is positive in these 2 quadrants. That's positive x. And the y or the sine is negative here. So I'm going to be in this quadrant right here. And then they tell us that cosine of this angle is adjacent over hypotenuse. So this would be 3/5. So what is this side here? 4. And it's negative 4 because it's going to the right and it's going down if you're applying that point. So it is negative. So that means that sine is opposite over hypotenuse, so it is negative 4/5. Then we do some fractions. 2 times negative 4 times 3 is negative 24, and 5 times 5 is 25. We call it a day. All right. Tangent to theta. So we'll start with the formula that we just derived. So tangent to theta is equal to 2 tangent, I guess I should say alpha because that's an A, over 1 minus tangent squared alpha. And then we use the information given to us. We already drew the triangle, so now we can find the tangent of that triangle. So tangent is opposite over adjacent, so the tangent is negative 4/3. So I have 2, and I'm going to plug in the fraction that I get, negative 4/3. And in the bottom, I have 1 minus, and I'm going to plug in negative 4/3, but this time it's tangent squared, so I have to square that. And then we just do some math right here. This times this is negative 8, this times this is 3, so that's negative 8/3, over 1, still a minus right there because I'm squaring the negative, so that's 16/9. I'm going to change this 1 right here to 9/9. So now I have negative 8/3 divided by negative 7/9. So fun. Then multiply by the reciprocal right here. I'm going to flip it, and I'm going to multiply. 3 goes into 9 3 times. And I get a positive, because that's a negative times a negative, 24/7. Are you confused, Harrison? 9 minus 16 is negative 7. Okay? I don't know. Let me read.